Okay, let's talk about energy, what it is, and what are some of the forms that it can take. And of course, to illustrate energy, I've included a picture that you all can probably relate to, someone with no energy. Well, energy is the ability to do work. So we would say that this little girl here has no energy, therefore she's not going to be doing any work. Work is simply the transfer of energy from a place or object to another place or object. Energy and work are both going to be measured in joules. Again, not joules, it's joules. So we measure both of them for capital J for joules. We have two types of mechanical energy that we're going to be talking about here. The first one is kinetic energy, which we abbreviate KE. Kinetic energy is, of course, the energy of motion. When you're running, when you're in a car that's speeding, or anything where there is motion, that is kinetic energy. The other kind is gravitational potential energy, or GPE. So that is stored energy due to essentially its position. Okay, let's talk about potential energy, or PE. Potential energy is energy that is stored due to one of two things. Number one, its position, where it is located, whether it is up above something or below something, or its shape. Sometimes if you deform something, it will store energy. Here, this example of potential energy, I'm stretching out a rubber band. Just because I'm changing its shape, I'm actually storing energy in there. Another thing that you'll see, if like a bow, if you were bending the bow, you were storing energy in that. So both of these are types of stored energy. This one right here, it's in its shape. Obviously, a wrecking ball is in its position. The higher it is up there, the more energy is going to be stored inside it. In this case right here, a really cool slow motion video of an egg being destroyed by a mousetrap there. There's a spring in there. That's the part that when you deform it, it stores energy that it can release like that. Or if you've ever seen people who put giant rubber bands around watermelons, which I don't recommend you try, but if you do, please videotape it. But that rubber band right there, a lot of stored potential energy in there, and it all releases. This one right here, at least they're wearing safety glasses, even though that just doesn't look safe. My favorite is it looks like how you can actually see her hair being blown backward. Anyways, a lot of stored potential energy in that rubber band. This one right here, I love to show this guy here because, boy, he's just so gosh darn determined and doesn't give up. But here we're looking at how energy is stored in different ways. Here it's stored by his gravity. Here it's by the elastic potential energy, and then of course he ends up with kinetic energy. So kinetic, elastic potential, gravitational potential, back to elastic, and finally he ends with kinetic the way he started. Gravitational potential energy. That is potential energy stored due to an elevated position. It's lifted up. It's on top of something. This little boy right here at the top of the mountain about to do something not so bright has a lot of stored potential energy. When his parents told him he had potential, they didn't really mean he was smart because, look, not even a helmet. Idiot. Anyways, gravitational potential energy, we calculate its mass times gravity times height. M is mass. As long as we're on Earth, the gravitational constant here is going to be 9.8 meters per second squared, and h is going to be the height. Click right up here for some actual practice problems with gravitational potential energy. So you just shorten this as mass times gravity is weight, so it's essentially just how much you weigh times how high you are to calculate that one there. Potential energy does not depend upon the path, just how high you are above a certain area. It doesn't matter how you get down there. Whether he fell off a cliff or went down a ramp, his potential energy remains the same. Obviously, it'll change his kinetic energy. My physics teacher said I had potential. Then he pushed me off a building. Get it? Because it's okay. I like to show this example here because you can see a massive amount of potential energy is released, turned into kinetic energy of this water here, all because of the height of that dam. It stores up that potential energy, as gravitational potential energy, and when that water comes roaring out, there's just a fearsome amount of kinetic energy released to that. All due to that difference in height between the top of the dam and the bottom. And you can see like this is enough power to essentially just rip apart a gorge to essentially make a valley where there wasn't one before. That's the power of potential energy. All right, kinetic energy. That is the energy of motion. Examples of this, heat, sound, radiant energy, just stuff radiating off. How we calculate kinetic energy is 1/2 mass times the velocity squared. Right here, I'll have a little bit of practice problems on kinetic energy if you feel like looking at those. M is mass, V equals velocity. Remember, when you're squaring it, make sure that you're only squaring the velocity, not this entire side of the equation. So 0.5 times the mass times whatever the velocity is squared. All right, so here's some types of energy. You need to know these. Mechanical energy, that could be both kinetic or potential energy. We could have thermal energy, which is essentially heat. That is total potential and kinetic energy of all the microscopic particles in an object, all of them moving around. The faster they're moving, the more heat there is, the more thermal energy. Chemical energy, that is energy stored in chemical compounds, whether it's gasoline, don't drink that, or fruits which have sugar in there, which you can eat, but don't put them in your gas tank, obviously. Or electrical energy, that is energy from electric charges, more on that in a couple of units. Or electromagnetic energy, a form of energy that travels through space in the form of waves. Finally, nuclear energy. That is energy stored in atomic nuclei, and God help you if you actually break those atomic nuclei, because there's a lot of energy released, and you better have something to do with that energy, or else explosion time.